So in this video, we're going to be going over angles and directions. And there's a couple different ways or different call-outs in which angles are specified. But let's go ahead and start with finding arc length. So if you have a circle, it's going to have some radius r, and then if you're just looking at that slice of the circle, it'll have some angle theta, and the arc length is that distance there, and we call that s. And so the equation to find s, it's going to be s is equal to r times theta, but it's really important that theta is in radians. So most of the time you'll be given theta in degrees, and so in order to convert from degrees to radians, you just need to remember that pi radians equals 180 degrees. And the best way to visualize that or remember that is to remember your unit circle. And so over here, we're going to have pi halves, 3 pi halves, and 0 and 2 pi. So in order to get from here over to pi, that creates a straight line, which is 180 degrees. So 180 degrees is equal to pi. So just for a quick example, if we want to convert 37 degrees to radians, you're going to start with your known value, 37 degrees, and then just set up a unit conversion. So we know that there's 180 degrees in pi radians. So then your degrees will cancel. And you can just go ahead and plug that into your calculator. So you're going to get 37 times pi divided by 180. And so that's going to be equal to 0.646 radians. And so conversion is that simple. So then if you wanted to find, let's say find arc length of a segment with radius equal to 500 feet and a central angle of 37 degrees. Now I've already converted our 37 degrees to radians, and so we just use this equation from up here. And so we know that our arc length is going to be equal to radius times our theta, given in radians. So our radius is 500 feet, and our theta is 0.646. And so our arc length is going to be equal to 322.9 feet. And so it's really that simple to find arc length and to convert from degrees to radians. So the next thing we're going to go over is our azimuth angles versus our bearing angles. And so really the only difference between these two is where they're being measured from. For your azimuth angles, they're always going to be measured from this axis here going clockwise. So if we had some segment in there and we wanted to know the azimuth angle, it would be this angle here. However, bearings are denoted by north, south, east, and west. So if we had this angle here, you always start at the north or south and then go over to the angle. And so whatever this theta is here, you would denote it with a north and east because it's in the northeast quadrant. Again, you always measure from the north side over to that angle. So if we had one over here, you go from the north side over to that angle. So this would be theta here. So you'd have a north, theta, and then west because we're in the northwest quadrant. But if you had an angle coming down here, since it's in the south half of that origin, then you measure from the south over to your angle. So you'd have a south theta east. Whereas this one over here, again from the south over to your segment in question, that's going to be a south theta west. So if we do an example of this, if we've got, let's say we know the azimuth angle of some segment is going to be 147 degrees. The first, and that you want to convert that to its bearing. So find the bearing angle. The first thing you're going to want to do is draw a picture of this so you can visualize and see which quadrant it's going to be in. So we know that 147 is going to be down in this quadrant because this line here is 180 degrees and this line here is going to be 90 degrees. Because again, you always start from your north line here for azimuth angles. And we know that there is 147 degrees. But we want to find the bearing angle, which it's in the lower half of this quadrant. And so you start from your south, go over to your angle. And so this here is going to be our bearing angle. And so we know that a straight line is 180 degrees. So that there is 180. So if we do 180, subtract this here, we'll be left with our theta there. So theta equals 180 degrees minus 147 degrees. And again, you can plug that into your calculator. And you're going to get 33 degrees as that theta. And then for bearing, you just have to attach your two directions. And so again, this is north, so this is east, south, west. And so it lies in the southeast quadrant. So we're going to do south first because that's where we start our measurement. And then 33 degrees east. And that's our bearing angle. Now, if you're given a bearing angle, let's say bearing angle equals north 30 degrees west. So the first thing you're going to want to do, again, is draw a picture. So we're up in the north half, and then the west quadrant, so we're over here somewhere. And that's going to be 30 degrees. And we want to find the azimuth angle. So again, the azimuth, you're going to start at your north and then work your way clockwise till you hit that. And it's going to be that angle there. So we know that each quadrant is 90 degrees. So we're going to have 90 degrees plus 90 degrees plus 90 degrees plus whatever this angle here is. Or you can recognize that all the way around is 360 degrees. So you can do that minus this here and you'll be left with the leftover. So that's a little bit easier, so I'm going to do it that way first. So we're going to have 360 degrees minus 30 degrees equals 330 degrees. And that's going to be your azimuth angle. Or if you like to just work your way around, it's going to be 90 degrees plus 90 degrees plus 90 degrees plus whatever this angle here is, which we can calculate as 90 degrees minus 30 degrees. It's going to be 60 degrees. So 60 degrees there. And so we know that 90 times 3 is going to be 270 degrees plus 60 degrees. You're going to be left with, 330 degrees. So again, those match, which is good. Again, whichever way you want to do it is okay. It doesn't matter which approach you take because you're going to get the same answer. So the next thing that you might be asked as far as angles and directions go is to find the interior angles of some traverse shape. And so obviously your interior angles are going to be all the angles on the interior of your shape. And so a lot of times you'll be given a bearing here, a bearing here, a bearing here, a bearing here, bearing here, bearing here. And you'll be asked to find the interior angles. And the best thing you can do is to just draw these little north lines and use your geometric properties, the properties that you learned in geometry, in order to find your different interior angles. For example, if you had a bearing here, A, B, C, D, E, F. One thing to note about these bearings is they always go from like your lower letter to your upper letter. And so this bearing angle here is referring to your bearing angle at A going to B, which would be denoted as A, B equals whatever that bearing angle end up being. If it was BA equals something, equals some bearing angle, then it's going to be referring to the angle, your bearing angle at B going to A. All right, but if we have this bearing angle here, so A going to B, then we know that that's going to be this angle here. But because of our geometry, we know that opposite interior angles equal each other. So this angle here is going to equal this angle here. And then you would be able to find this angle here because this plus this has to equal 90 degrees, which this piece is going to be part of your interior angle at B. But then you can also use this over here to help you. So yeah, you just kind of have to work your way around using these principles of geometry in order to find your interior angles. And I have a full example of one of these in the written example. And honestly, each one of these is so different that it's kind of hard to give you a good example of one that you might see. So if you do have questions about one you're working on, head over to our homework help page and we'll be able to get you specific help there. And then finally, the last thing that you're going to have to be able to find are deflection angles. So again, you're going to have some shape. And it's going to be your points, A, B, C, D. And so your deflection angle, if you wanted to find your deflection angle at A, what you're going to do is you're going to follow this path as it leads to A. And you're just going to continue that out, and then you're going to drop down to the line that goes to the next letter, so A, B. So this is going to be your deflection angle at A. And then to find B, you start at the letter right before B, which is A. So you start at A, go over, cross through B, continue that, and then drop down to the next letter, which would be C. So this is your deflection angle at B. And then again, you'd start at B, go through C, drop down to D. That's your deflection angle at C. And again with D, go through D, drop down to A. That's your deflection angle at D. And the cool thing about these is that if you have your interior angles, then your deflection angle is just going to be 180 degrees minus your interior angle equals your deflection angle. And so it's really as simple as that. Deflection angles aren't bad. Again, a lot of this is just going back to geometry and remembering, you know, things like, let's see, if you had some line here, things like opposite interior angles, or just opposite angles. Those are going to be equal to each other. The biggest one you're going to use, though, are these opposite interior angles, and just remembering that as long as you have two lines that are parallel on the line in question, then opposite interior angles are going to be equal to each other, which again, this angle would then be equal to this angle, which means this angle is equal to this angle. So then you've got your opposite exterior angles as well. So if you need to, you can go back and review those geometry principles. If you are struggling though with recognizing those different rules and things, head over to our tutoring page, and I'll be able to sit down with you and go through one of these and explain all those different principles to you.